Q at due north 30 Newton, while P at due east 40 Newton. We have to get the resultant R. We have that from Pythagoras theory, the square root of the hypotenuse is equal to the sum of the squares of the other two sides. R squared is equal to P squared plus Q squared. R squared is equal to 40 squared plus 30 squared, which is equal to 2500. R becomes square, crossing over will become square root of 2500, which is 50 Newton. Also, tan theta from trigonometry, law of trigonometry, is equal to 30 over 40, which is 0.75. That is theta. Tan inverse of 0.75 is 36.9 degrees. Therefore, the resultant is 50 Newton, makes 36.9 degrees with 40 Newton force. Triangular forces. This states that if three forces are in equilibrium, they can be represented in magnitude and direction by the three sides of a triangle taken in order. Suppose x, y are the representative algorithm sum of the resolved components in two perpendicular directions of three forces P, S, T in equilibrium. Figure 137. Then, since SY can each be represented by the sides of a triangle drawn to scale, the resultant R is given by R squared equals to S squared plus Y squared. Figure 237 shows the resolution of forces at a point. Example 8. Three strings are attached to a small metal ring. Two of these rings makes an angle of 35 degrees with the vertical, and each is pulled with a force of 7 Newton. What force must be applied T, the third string, to keep the string stationary? Solution. Looking at the diagram, the body is hung by a string 7 Newton at an angle 35 at the left, 35 at the right each, to suspend a body T of resultant. So we can represent the forces on a triangle. If the left hand side of the force resolved is 35 degrees is put on the first coordinate at a point B, then the second coordinate will be at point C, which is for the right hand side of the force resolved. Then the resultant, or which the two forces are carrying, will be AB, which is the T we are looking for. Since the string is in equilibrium, we use triangle of forces. Use Lenz's theorem. T over sine 110 degree equal to 7 over sine 35. Therefore, making T the subject of the formula, we have, and putting in the values, the unknown values, we have in bracket 7 sine 70 degrees all over sine 35 degrees is equal to 11.4547 Newton. Note, the condition for the equilibrium of three non-parallel coplanar forces are: the line of action of the force must meet at a point, the algebraic sum of forces at a point must be equal to 0, all the three forces must be coherent. Example 9. Figure 1.39. Three forces. In figure 1.39, three forces F1, F2, and F3 acting at O in equilibrium. If the magnitude of F1 is 10 Newton and the magnitude of F2 is 5 Newton, calculate the magnitude of F3. If knowing that F1 and F2 are at an angle of 60 degrees. Solution. Magnitude of F1 can now be represented since F1 and F2 are at an angle of 60 degrees. Then it can be represented by the two sides of a triangle, and F3 being the resultant of the force. If Q is 5 Newton, P is 10 Newton, and theta is 60 degrees, using cosine rule, we have that r squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos 120. R, capital R, is equal to square root of, in bracket, F1 squared plus F2 squared minus 2F1 F2 cos 120, closing bracket. R is now substituting and putting in the values. We have square root of, in bracket, 10 squared plus 5 squared plus 2 times 10 times 5 cos 60 degrees. R is equal to square root of, in bracket, 10 squared plus 5 squared plus 10 times 5 times 0.5. R is equal to the square root of, by doing the sum, we have 175, which will give us 13.2 Newton. Since F3 is in equilibrium of F1 and F2, the magnitude of R is equal to F3, which is equal to 13.2 Newton, but the direction of F3 is opposite that of R. Simple harmonic motion. Definition. Simple harmonic motion is the motion of a particle whose acceleration is always directed towards a fixed point, directly proportional to its distance from that point. Summary. In simple harmonic motion, the acceleration a of an object is equal to minus omega squared y, where y is the distance or displacement of the object from the fixed point. The period t of the motion is equal to 2 pi over omega, where t is the time to make a complete to and fro movement or circle. Frequency. The frequency f is equal to 1 over t, and its unit is hertz. The period t is equal to 2 pi over omega, which is equal to 2 pi square root of 1 over g. The magnitude r of the motion is the maximum distance on either side of the center of oscillation. The velocity at any instant v2 is equal to omega square root of r squared minus y squared, close bracket. The maximum velocity v max is equal to omega r. Total energy is equal to half m omega squared a squared. Relationship between linear speed v and angular speed omega is given by v equals to r omega. Linear acceleration a and angular acceleration omega squared is given by a equals to r omega squared. Example